Hey guys, welcome back. Today we are kicking off a project for myself at home. Okay, now any of you that have a little workshop area at home, or even if you've been in a shop at school or at another place of work, you know that workspace or table space is critical for success. You know, most of what we're welding and fabricating is relatively smaller pieces. And so it's helpful to get them off the floor and get them up on a table. Okay, and so today I am starting the job of fabricating myself a new metal work table. Today with my table, I'm thinking that this is something that I want to last, right? All the good tables that I've worked on, they're heavier in sin, but they're made to last, right? I've worked on tables that are twice as old as me. And they're still going strong because they're made well, and that starts with your raw materials. Okay. That being said, we do want to balance longevity with what we have as well as cost effectiveness. And so today I've kind of found a solution that meets the best of both worlds. Okay, and that is using a lot of scrap material or material laid around. So today, at least for the frame and the legs of this table, I am using two pieces of material that frankly we've had sitting around the shop for years. Never really have found a decent use for them, and so we're going to put some of them to use. What this means is that they are relatively considered scrap materials. We're going to really discount that price just to get them out of the shop. Okay, so the first thing we're using is this piece right here. This is 2 by 3 by 3/16 inch angle iron. Okay, and here, I'm going to pull out another one of my pieces here because it has it written on it, 3 by 2 by 3/16. So what that refers to here is it refers to the profile view. Okay, whenever we're talking about structural steel, we always look at the profile or looking at down the end of it. Okay, so what we mean by that is we have a 3-inch leg. Okay, so between my fingers is 3 inches by 2 inches. Okay, and these are actual measurements. Okay, it's a little bit different than lumber, where like a 2x4 isn't actually 2 inches by 4 inches. It's a little bit less. Steel is the actual measurements. So 3 by 2, excuse me, by 3/16. 3/16 is the thickness. Okay, and so that is. But next, we're going to look at our frame. Okay, now our table frame is going to be a little bit thicker. This is actually going to be out of material that's 3/8 inch wall thickness. Okay, this stuff is 2 inches by 2 inches by 3/8 inch wall thickness you have to make whenever we're working with thicker walled material. Okay, typically anything other than 1/4 inch wall thickness. Okay, which is about right in the middle of these two, right? Yeah, 3/16 to 3/8 is right. Quarter would be right in the middle. Anytime we're working with something over 1/4 of an inch thick, we are not going to be able to weld that effectively with a single weld pass. Okay, and so we've got to figure out a way to pump more heat in. Essentially what happens is the heat or the weld will not get hot enough and it will not fuse deep enough for an effective weld. So as we go through this process, you're going to see a couple different options for addressing that issue of getting enough heat into this weld. So stay tuned. As I mentioned earlier, really anything over 1/4 inch, we need to do some sort of manipulation to the metal or to the weld puddle in order to get adequate depth of fusion. Okay, with just running a straight single stringer bead, we will not get the depth of fusion, and our table and our project could. So we're going to imagine that these two, that this drawing right here is our imaginary pieces we're welding together. We're going to say they're 3/8 inch thick, so just like what we're doing, and we're going to say that this joint right here, this line right here, is the point at which those pieces mate up, right? So with my project here, with most projects, well, maybe not even most projects, but at least with this project, we're talking a square butt or a square groove. Okay, by square groove, we mean that this edge is 90 degrees to the length of the material. So that face is at a perfect 90, or well, it should be perfect 90. All right. So when we weld this, then we take our weld and we run it over the top. We probably get a profile that looks something like this, right? Now, when we do that, sure, all we see is this visible part of the weld, but what's happening here is actually it's kicking heat into here and it's melting down into that base metal. All right. Now, the thicker the material, the more heat we need. So typically in a welding setting, what do? Well, we turn the amperage up. Okay, we kick more electrical power into this weld and we get the desired result. However, with 3/8 inch thick material, most people, especially in a home shop, even in my shop here, we do not have an easy capability to just blast down through that 3/8. Now, there is ways we can do that. We can use a process called spray arc gas metal arc welding. GMAW is a process. Spray arc welding is a method of getting a lot of heat in there. Me personally, I can do it. I'm not an expert at it. I'm not very good at it. And so I want to stick with what I know. Plus, this machine that we have to do spray arc welding in our shop, when we purchased that was a $6,000 machine, right? Right now, I'm pricing out a new machine for my personal use. And I'm sitting here as a teacher on a teacher's paycheck, cringing at about a $1,500 price tag. Okay, so this is an expensive machine. Not likely you're going to have one of these at home, right? And so we need to think of a different way. So to do that, we can do what's called beveling. Beveling. Okay, so I mentioned this layout here is called a square groove. Another O there. Spelling's hard. All right, square groove. The edges are square. All right. What we can do is either do a single bevel or a double bevel. So I'm just going to redraw everything over here. Okay, we're going to make it kind of the same approximate proportions. Everything else the same. Okay, there's our square groove again. This is just a rough sketch here, guys, so try not to razz me too much over poor drafting abilities, but that is what it is. So what we're going to do is actually draw in, or we're actually going to create a groove weld or a V groove. A V groove weld. This is just what it sounds like. It sounds like we're making a V in our joint. And so what we're going to do is we're going to somehow cut an angle in each of these pieces so that this part becomes waste. And now this is our weld. Okay. We might leave a little root opening right here at the base of the weld or at the root of the weld. We might not. It depends on what you're doing. Okay. Typical V groove angle. Usually I shoot for 30 degrees. Sometimes the weld procedure specification or the parameters for a weld calls for something different, but this is at least a good starting place. Now, what this allows us to do is it allows us to use a bog standard wire feed welder, GMAW welder, relatively lower amperages, relatively lower heat input, but it still allows us to get good heat fusion. Okay, and we can do that by laying multiple beads in here. So typically we'll lay a bead here and then we'll just start stacking. All right, we start stacking until this is all filled up. All right, now for this 3/8 material, I would estimate we're going to have somewhere between 3 and 6 passes, depending on the settings and just how it welds. Okay, but that is a very good way to put this thicker material together. All right, so next up, we've got to consider exactly how we're going to get this groove in here. All right, so we have a bunch of different ways, right? We could take a flame torch and actually cut that groove in there. It's It's probably the most efficient way to do it, especially if you're steady with the torch. However, I've got some new equipment here that I do want to try out. Okay, and so that's what I'm going to be using for this. Okay, and that revolves around this tool right here. Okay, this tool is just a bog standard angle grinder, right angle grinder, probably one of the most common metalworking tools in any shop or home or home shop. Okay, we have our spindle here, we attach a wheel there, and that wheel is what allows us to do our cutting. Now typically with angle grinders, we have a wheel that looks something like this. This is just an abrasive wheel. It's a stone type wheel. Pretty good at hogging off a lot of material, and it's very cheap. Okay, this wheel is just about at the end of its life, so I do have to replace it pretty quick, but it's fairly cheap and it does a fairly good job. Okay. However, that doesn't really leave a very good finish. Okay, so we might move to something like this. This is called a flap wheel. A flap wheel. All right, essentially what it is it's little flaps of sandpaper glued onto a wheel. All right, you can see the profile there, how they're glued. And we can use this in much in the same way. Use it to grind down material, gets a real smooth finish if we use it properly. Problem with these is they're expensive. Okay, they're expensive. Quite a bit more expensive than our bog standard grinding wheels. Okay, so being that I've got some time here as a teacher, you know, with this whole distance learning thing, I've had some time to explore things. And one finishing technique or one finishing tool that I've heard talked about is what's known as a fiber resin disc. Now, a fiber resin disc is essentially a piece of sandpaper. Okay, here are 3 examples of varying grits. Okay, we have a very coarse grit. This will take off a lot of material, a moderate, and a very fine grit. Okay, we can actually use this on metal. To do that, we use what's called a backer plate or a backing pad. Okay, just out of curiosity, I went ahead and bought one of these backing pads. This one is a fairly cheap model. If I'm honest with you, I kind of cheaped out on this because I wasn't sure exactly how this would work. I just wanted to try it. We'll see how it goes. And so, you know, I want to learn something. That's the whole point here, guys, is to learn something, try something new. I'm going to try this, see how it works. I will get to beveling and hopefully give you an idea of the results I got.